day. Therefore, 2 days of these problems, you won't have the excuse of I don't know how to do them. So, assume the random variable x is normally distributed with a mean of 50 and a standard deviation of 7. Compute the probability of the population being between 35 and 60. What is that probability? Yeah, just come on in whenever. That's fine. How was breakfast? Was it good?
I didn't eat.
Oh, you didn't eat? Should have at least went back and got a biscuit. Now, you don't really have to draw a picture with these type problems, but in your homework, in your notes, you might want to draw a picture. And it's A, between 35 and 60. You can use your calculator or use the table or use both. You can't use common sense, so that's not going to be right.
For that one.
For this part, but the second part, you got to give the probability. Just answer half the question, that's all. Don't worry about the other half. You'll just make a 50 on the test. And then you can live in a van down by the river. One of the students, I think it was this lady right over here, came up to me and said that some of your calculators have the advantage of finding to the right of the curve, and that's great. You can use that. Don't ask me. I don't know. Okay? I do good to even have a calculator. I don't even have one. But anyway, most of the time, it'll do left or it'll say right. So you can hit whichever one you want to, but that depends on the question. This one, you're going to have to do in the center or middle between 35 and 60, but of course you got to turn 35 and 60 into z-scores. So we've established that it's A. So now we just got to turn 35 into a z-score. So z sub 35 is equal to 35. Is everybody listening, or are you talking while I'm talking? Which one is it? Some of y'all just can't handle simple, basic concepts, whoever it is. I don't know if it's a kindergarten thing or a medical issue or what. Okay, so whoever it is talking, shut the hell up. Thank God. I've done passed rude many times ago. 35 minus 50 over 7. And 35 minus 50 is what? 15? Over 7. So that's 2 and 1/7. Or what does the decimal come out to be?
Negative 2.14.
1/4. Alright, so there's one. So at this point, you've got negative 2.14. And you want to go to 60, so z sub 60 is equal to 60 minus 50 over 7, which is equal to 10 over 7, which is equal to 1 3/7, which is what? 1.48, or what is it?
1.43.
1.43. So now you've got the z-scores you need to actually find. So take second, bars, normal, whatever it is, PDF or CDF.
Wait, isn't it in?
No, because you're going z-scores. Okay, second bar is normal what? CDF?
Yeah.
Normal CDF, and then you read from left to right, so that's going to be negative 2.14. Now I'm using the old PIA 3 format, 2.14, comma, 1.43. And when you get through punching it in your calculators, what do you get? Give me 4 digits because it's an area.
0.9075.
9075. Now, of course, you can go back to your empirical rule. And that's 0, 1, 2, -1, -2. And that's 34, 34, 13.5, 2.5, 13.5, and 2.5. And we know that one of them is around -2.14. 2.14 is right in here. And the other one is 1.43, which would be in here. So we know these two are 68%. And then half of 13.5 is 7. So that's 7%. And this is 13.5 because it goes past that. And let's say this is 0.5. So that's 14. 14 and 68 is what? 82. And 82 and 7 is 89. So just by common sense, empirical rule, I'm getting around 89%. And it's 91%. So, and that's how you should tackle those problems. Always check yourself, because just because you put those z-scores in does not mean it's right. You could have an error. Okay? So we're going to hit A. Check answer. And 0.9075. Okay? All right, that's the same type question, so you can do that for homework. Let's go over. I'm just going over different problems that you'll have in your notebook in case you, well, if the computer will ever cooperate. Okay. There we go. That's the same type problem. Same type. Same type. Same type. It'll only give you like 5,000. Okay, do that one. Now the reason this one is different is, one, they don't give you the choice of a picture, but they also don't ask you for the area. Do they? Let's see. No. Find the 15th percentile. They're wanting a z-score and x. They're wanting x. So this one we haven't seen before, because you got to use Oz plus mu. Remember, there's two formulas in this section of 7.2. There's the z is equal to x minus x bar over standard deviation, or x minus mu over standard deviation, x minus mu over sigma. So that's for the population, that's for the sample, but it doesn't matter, it's the same formula. And x is equal to Oz plus mu. That one, and you can, there's your two formulas. Number 1, number 2. So if you want to pass 7.2, and you want to pass this next test, because 80% of the test is coming from 7.2, you need to know those two formulas. And x is the measurement that goes along with the question. Okay? Other than that, you're going to be dealing with what kind of score? The z-score. So if the z-score is between 0, 1, and 2, and -1 and -2, then what does these scores have to do with? X. These could be test scores. It doesn't really say, it just says numbers. Okay, these could be test scores. X represents, in this problem, a test score. the test score that represents the 15th percentile. So go out here, and with this question, X equals the test score that represents 15th percentile. Now, this was weights, then it'd be X is equal to the weight that represents. If this was heights, X is always representative of the initial measurement, whether it's a height, a weight, IQ test, score on a biology test, whatever the case may be. So let's just draw a picture so we'll know what the heck it's asking for. You got tired of drawing these things yet? You will. 0, 1, 2, -1, -2. Also, down on the bottom, we'll do it in a different color. 54 and 59 and 64 and 49, right? And 44 or 45, 44. All right? We just want the 15th percentile. Well, 15th percentile, if we remember, this is 2.5. This is 13.5. This is 34. This is 34. 13.5 and 2.5. Well, we know that 16% is weighted right here, so we're just going to drop it right there. And we're going to put 0.0, let's see, 15%. Let's say 15, so 15% is equal to 0.15, right? 0.1500. So now you're given the area, and you got to find the z-score. So now you use the inverse norm. So second, bars, inverse norm, whichever number that is on your calculator, because it's different on different ones. Inverse norm, and then you're going to put 0.1500 and enter. And I think it's going to be negative 1.1. What is it? Because that's where I guessed it. It's right around here. Negative 1 point what?
04.
That's all I heard was negative 1.04. 1.04 negative. So now you got a z-score, but that ain't what they want. If they wanted z-score, they would say find the z-score that blah blah blah. But they don't want to find the z-score. They want the score. So you got to take that and your information here and here and plug it into odds plus mu. So do that. Plug it into odds plus mu. Now, by test scores, what do you think it is? Well, let's see. This is 49. This is 44. I mean, did I just transpose 44 and 49? So that means there's 5 tick marks here. So I'm going to say that that's 1. So I'm going to say it's around 48. That's what I'm going to say. So let's do odds plus mu. So we'll do it in green. So that'll be X is equal to odds plus mu. Everybody's listening. Okay? 5 times Z is negative 1.04 plus 54. And that's going to equal negative 5.2. Somebody check me. Negative 5.2 plus 54. And that's going to be 48.8. Now they may say round up. So I would say, no, it says round to 2 decimal places as needed. So they are wanting the X. They're wanting, they don't really, no, they don't. They don't specify. So 48.8 what? Is it 48.8 even? Okay, well, they either want the Z-score or but I showed you how to do both. This problem does not say, it's not very definitive, so I'll take either answer. Oh, that reminds me, I got to write a note to y'all today I'm going to create a new bonus question for the next test. I'll explain toward the end of class. 48.8. Okay, they do want the test, but see, they didn't specify, so I think that's a kind of a, usually they ask for the test score that represents the 80th percentile. All right, you try this one. It says assume the random variable x is normally distributed with 50 and standard deviation of 7. Find the 80th percentile. Find the test score that represents the 80th percentile. So that means your area is going to be 0.8000. Draw a picture so you can do the empirical rule. So you have some idea of what it's going to be.
You said the area would be
.8000. Y'all haven't had a test recently, have you? Not in the last couple of days? Okay, so nobody in here wrote this email. This is just the other classes that I have. Due to numerous emails, There's the new question that I'm going to put on. If I miss a test question on Hubert's test and the correct answer is the same answer as mine or written in a different way, I should write several emails to Hubert with the last one saying, hello, go into hysterics, ask Hubert about it after class, or call Hubert's office several times.
See.
Good job. Wonder why I'm not responding to the person that's calling several times or emailing several times. Because I've already covered this. You remember when I first pulled the test up, the second day of class? I pulled it up and I said, if you have a question that you still can take it 3 times, all right? So first of all, if you have a question that you question, take the test again, okay? But if you got a 98 and this question is keeping you from 100, then yes, by all means, see me after class. But emailing me is just going to get lost in emails and I'm going to forget about it. And plus, when you have, in the real world, this is real world, not your mom and dad's basement, this is the real world. If you have something that you need to communicate, what should you do? You should go to the person in person, okay? If it's something that has to do with contract, if it's something that has to do with something important at work, and what's more important than your grade? Nothing, okay, in this world. All right, so if you've got a question about your grade, you go to the source. You go to the teacher and you ask the teacher. Okay? So that's going to be another, of course, it's going to be worded different. I don't know how I'm going to word it yet, but I just don't understand why people don't listen. Especially when I give you easy things to remember, like challenge question. You see me after class, period. Not before class. Why not before class? Because I'm trying to what? Get ready for class. And then we have to talk about football, and then we have to talk about current events. And that just gets in the way of all that. All right? So remember that question. You may see it on the next test. All right. So I'm just going to draw it because I have no idea what the question's asking because I forgot. So,
For the 80th percentile.
okay, find the 80th percentile. Well, this is 2.5. This is 13.5. 34. Is everybody listening? Well, I don't hear everybody listening. 13.5 and 2.5. Now, I think at one point, this is like 80-something% right here. What is it?
It's
80 exactly?
Yeah.
All right, I'm going to take my handy-dandy red marker, and I'm going to go just right in here, and I'm going to put 80%. I thought it was 81%. Okay, sure. All right, 0.8000. Now, while this does fall on the 1 mark, you can't say, okay, it's 1, and sometimes it doesn't work that way. Remember, the empirical rule is just by what? It's estimate, right? It's not as detailed as actual calculation, so you can't, and it may work out to be 1, and that's fine. But you better make sure, because it could be 1.05 or something like that.
I lied.
What?
I added 64 plus the 16, so 68 plus 16, so that's not good.
Okay, well, what is 2.4? What are these 4 added up?
84%.
84%. All right, so let me, now that you've totally messed this question up, I'm sorry. Let's go back and, there we go. All right, so you said it's how much?
84 is
84, so 81 would be right in here. Or 80, I keep thinking it's 81. 000. So we're talking about, this is 1, this is 2, 0, -1, -2. We're talking about probably, I'm going to say, approximately 0.8. Z is equal to approximately 0.8, and that's by guess. All right, so now what do we do first? Well, we don't know the z-score. So we got to find the z-score for 0.8. So second, bars, inverse norm, because we're given an area, and 0.8000, and what does that come out to be? 0.84. So our z-score is equal to 0.84, and we estimated, that's what we'll swivel with the, we estimated around 0.8, so we know that's about right. Now we just got to plug it into Oz plus mu. We'll take our green pen, and x is equal to Oz plus mu. X is equal to, standard deviation is 7 times 0.84 plus 50. And somebody give me that number. 55.88. Which most questions would say 50, round to the nearest, but it says round to 2, so it's 55.88. Now the reason people miss these questions are they're used to doing the other questions, which doesn't have a 50 and a 7. And they just think it's 0, 1, and 2, and that's why they don't make the shift between the two questions. There's two types of questions. So that's what happens. And they get confused. So that's why we're going over these. We're spending nothing but today on going over these questions, because that's where students have the biggest problem. All right, we did one like that one. So I don't want to do that one because that one's about the same. Let's see what this one says. The mean incubation time for a fertilized egg kept at temperature 7 days. Suppose that the times are approximately normally distributed with standard deviation of 2 days. Okay, this question is not a question that is asking for a z-score or anything. It's based on the empirical rule. The mean incubation is 17 days. What's the standard deviation? So they want you to draw a picture of it. Now, I have no idea what this is going to ask, but I know this question, it doesn't have enough information, and it's not asking for you to do an area or so it's just wanting you to draw a picture. So 17, 19, 20, 1, 15, and 13. Now it says answers A through E. Good gracious alive. I'm not going to give you one like this on test. If I do give you one, it'll be just this question. And that's all I want. Okay? Why don't they just put the graphs on? Why are they doing this? This is a new question. I've never seen this question before. So let's go over and see which one it is. Okay, that's not right. 13, 11, 19. That looks right. All right, 15 other parts of this question, which is stupid. All right, it says, find and interpret the probability in random fertilization that less than 13 days. So that's what? 0.0250? That's 2.5%, is it right? Empirical rule. Yeah, that's why it helps to have these things copied, especially if you have the empirical rule already on it. Because that's the only thing. You're not given any information. So this question is basically an empirical rule question. And less than, so that's 2.5, 13.5, 34, 34, 13.5 and 2.5. And the rest of the questions are probably going to ask you questions like, what's between 15 and 19? What's above 21? Those type of questions. So the question it's asking right now is, what's below 13? And that's 2.5%. So I'm going to go through this question to kind of kill 5 birds with 1 stone. But as far as an empirical rule question on the test, I would just ask you 1 question, maybe 2 the most. I wouldn't ask you 15 like they're asking. Check answer. If I did, then that means there would be less questions on the test. Okay, interpret, blah, blah, blah. Where's the question? If 100 fertilized eggs are randomly selected, blank of them would be expected to hatch in 13 days. The average proportion of the way to hatching all the eggs fertilized in the past 13 days is in every group of 100 fertilized eggs, blank will hatch in less than 13 days. Oh, this is a play on words. A and B, A and C is about the same thing, except for it all depends on what your definition of is. They're asking you to split hairs here. Expected. I would say expected. So what is 2.5% of 100? 3? Yeah, it's 3. Should be 3. 50% is 50, right? Now, why did I pick A? Well, mainly I have no idea. I don't have no idea what B is even asking. The average proportion of the way to hatching all eggs fertilized. I don't even know what that's asking. All right. I know that these are asking, according to this graph, 3 of them would be expected versus what? Will. Will is putting a concrete, discrete prediction on it. Expected is giving you a little bit of what? A little bit of leeway. And y'all all know that we can't foretell the future. So the less concrete, the better. Now, I could be totally wrong here, and it could be B, if it's B, I have no idea what B is saying. Okay? Until they fill in the answer, and then maybe I can contextually tell you what B is asking. But the way it's written, has anybody got any idea what B is asking?
It sounds like it's asking about actual data because it's talking about the past 13 days. So I feel like
Well, we don't have that.
So that's not.
This is what messed me up right here, the past. I'm going to say 3. We got it right. Okay, find and interpret the probability takes over 21 eggs, 21 days. So that'd be 3 also. Oh, they want 0.0250. Really? They're going to ask the same thing? 3 of them would be expected. What letter are we on? Gosh. I told you it'd be between 15 and 17. I knew that would be in there. So 15 and 17 would be 34. So take 0.34 and multiply by, or wait a minute, they want you for 0.3400. And now take 0.34 and multiply it by 100, that'd be 34. So expected, right there, 34. Okay, can everybody say redundant? All right, would it be unusual? First of all, what is unusual? Anything outside of what? 2 standard deviations. Put standard deviations down here. So anything in here is unusual. and anything out here is unusual, and this in the middle is called what? Normal. Goes to that line and this line. Now let's go to the question. Probability of the probability of an egg hatching in less than 11 days is, yes, it'd be an outlier pretty much. Wait a minute, let's see. 13 minus 2 would be 11. So that would be an outlier right here. Outlier and unusual right here. So that would be point. But how do they break it up? Is this 2.2 or 2.3% in the book? I heard 2 point what? 2.3. So this is 0.2. So that would be 0.0200.
It should be 2.5 because we did. That's how we did it before.
No, but they're asking outside, less than 11 days, right here. Less than 11 days means that you're going to have to break up that 2.5 into 2.3 and 0.2 because that's what they're asking right there, less than 11 days. So it, I don't even know what they're asking. We'll look at the choices. So 0.0200, right? Is that right? 0.02, is that 2%? No, 0.0020. So it would be an outlier, but they would say it would be unusual since the probability is less than 0.005. They want you to find a z-score?
It's just the first answer.
Huh?
The other two are right. It's just the first answer they're trying.
Okay, so somebody take 11. They want the z-score. So this is ridiculous. They spend 99% on the empirical rule, but the one question right here, they want you to find the z-score. Well, that's something I would do. So 11 minus what? 11 minus 17 over 2. That's equal to what? Negative what? 6 over 2, which is negative 3. All right, somebody get due from 9999 negative to negative 3 in your calculator. What do you get?
The 0.2% of the one we are.
Okay, well then why were they showing the z-score in the solution? Okay, 0.02. Thank you. Maybe that's the error. Maybe I just don't know how to read decimals. 0.020. Is that better? See, they're giving you the z-score right here. So somebody do negative 9999 to negative 3 and tell me what you get. 0.0013. That is so stupid. You do 98%, 99% on the empirical rule, and then they stick in a z question. That's stupid. I wouldn't do that. Who's got a question? I thought I saw a hand go up. Do you have a question? Anybody? I thought I saw a hand. I'm sorry. Okay, stupid question. Not going to be a test question, but now, is the information in that question good? Yes, except for the 1z question. That's an outlier. It shouldn't have been in there. But anyway, we'll keep going. The more questions I do here, the better you are. Let's see. All right, let's see what this one says. The number of chocolate chips in an 18-ounce bag of chocolate chip cookies is approximately normally distributed, blah, 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 blah. All right, do this one. Because this is detrimental to you surviving in the real world to know where your chocolate chip cookie sits as far as, normal distribution. But who would be interested in this? Somebody that works at, who makes Chips Ahoy? Keebler or Nabisco? Nabisco. If you worked at Nabisco, quality assurance, would this be important to you?
Sure.
Would your paycheck rely on this?
Yeah.
Yes. And who knows? You may work at Nabisco one day. Who knows? I was going to be a mechanic.
You're also going to be a vet.
Yeah, I wanted to be a vet. But
What was your job in grades?
EOD, explosive ordnance disposal.
I'm
All right now.
I'm in the guard now.
Are you?
I'm signed up to combat.
Well, combat engineer and EOD has a lot to do with each other. We blow up stuff. We used to make little mines out of Copenhagen cans. We'd load that sucker with C4, put a poppet and a toothpick through the middle. You can make mines, put some tacks and stuff in there.
Thanks.
You got to get your hands on C4 first. Pyrex is even better. Anyway, but I'm okay now. I take the medication. All right, so draw a picture. That's what you can always tell about a veteran. The one that never says anything about them being a veteran, that's one that usually seen the most stuff. That's scary. The ones that holler about, I killed 15 people while I was over there, those are the ones that's usually packing boots in the rear that's never seen anything. Or not even in the country. They're up in Virginia covering for an active duty person that's over in the stuff. So.
For some reason, you said veterans, I was thinking veterinarians, and I was confused.
Yeah, I did get the two mixed up. I wanted to be a veterinarian, but I am one out of the two. I'm one out of the two. Okay, don't worry about it. I'll shut up. All right, so 1252. Okay, y'all gonna have to help me out. Do these two. What are they?
Oh, which one? Oh, 1381.
1381 and
1510.
15 what?
10.
This side
1123.
and
99. Oh, Jesus Christ. 994.
994. Y'all check to make sure everything's good. All right, and I'm going to put down below it, I'm going to put my green 0, 1, 2, -1, -2. Now, I have no idea what the question's asking, but we also need to put 2.5. You see why you need to copy this? Because this gets old. About 3 or 4 problems, you're going to be like, oh, I got to copy these things. And you need all 3 of these things on here. Now, this is going to change with each question, so you've got to leave that blank. But the 0, 1, and 2 and the empirical rule, you need to have it on each one. Unless you're just going to write it each time, and that, on a test, it's very old. What is the probability that the randomly selected bag contains between 1,000 and 1,500? Now, 1,000 and 1,500 is not on here. So therefore, you automatically know that this one is a what? Z-score. Unlike that last question that was totally stupid. All of a sudden they want a Z-score. Okay, this one is based on Z-score, so you know that was going to have to be. So let's go ahead and draw it. We'll do it in blue. We know 1,000 is, let's see, right in here somewhere. I'm just going to put 1,000 right there. And 1,500 is right in here. Now go ahead and figure out by common sense. We know that 68, I'm going to say 5 plus 68 and 5. 68 and 5 is 73. Somebody check me. Huh? 73 and add 12. What's 73 plus 12? All right, I'm going to say 85%. So I'm going to go over here and orange. I'm going to put around 85%. That's my guess. All right. So I know if I hit around 80 to 89%, I'm probably going to be somewhat correct. All right, so here we go. 1,000 minus 1252 over 129. Somebody give me two digits. It's going to be negative 1 point something. 1.3. What is it?
Negative 1.95.
1.95. That was way off. And this may be way off too, but we'll see. All right, now the other one is 1,500 minus 1252 over 129. Somebody give me that one. I say it's going to be 1.9.
1.92.
1.92. Now do your handy dandy between the two. What is it? Second bar is what? Inverse CDF or norm CDF. And somebody tell me what you get. Give me 4 digits. Negative 1.95, comma 1.92.
How many?
4 digits.
0.9470.
So I was off. The reason I was off was I read that bottom one wrong. Yeah, 994 is closer to 1,000 than 1123. I don't know why I did that. 994 should be right in here. I mean, 1,000 should be right in. Yeah, right in there. I read that as 1,000. Okay, so that's where my mistake was. Now, what does this say? What is the probability that's fewer than 1,000? Well, you already got the z-score for 1,000, right? So just go from negative infinity to what? That's to negative 1.95. Somebody give me that one. 4 digits. Negative 9999 to negative 1.95. So that's less than 1,000. That'd be right in here. So it's going to be about 3%. What is it? 4 digits.
0.0256.
Okay. What proportion of bags contain more than a 1225? So let's change 1225. Let's do it in a different color. 1225. We'll do it in magenta. So 1225 minus 1252 over 129. Somebody give me that z-score. 2 digits. It says more than, so that means we're going to positive infinity after we get this z-score. What do you get? 2 digits. It's going to be a negative. Okay, now that's not a hard calculation.
-2.
Negative 2 what?
1.
Negative 2.1?
Yep.
Did everybody get 2.1?
Well, I got negative 0.21.
Yeah.
Negative 0.21, comma, positive what? Infinity. Somebody give me 4 digits. Because it says more than, so that's why I do negative 0.21 to infinity. What do you get? 4 digits.
0.5832.
5832. So A, let's go with A is right here. So this is A. B is right here. C is right here. Now D, what percent contains within, what is the percentile rank of a bag that contains 1,025? So 1,025, we'll do it in a different color. Go away. Why isn't it going away? $1,025 minus 1,252 over 129. Somebody give me 2 digits for that Z-score. This is D. Two digits.
-1.7.
Negative 1.7, and then 1.7 what?
6.
Okay, now go from negative 9999. Okay, you don't need, you just need to, okay, you can. You need to change that into an X. Sorry. Change that into Oz plus mu. So X is equal to 129 times negative 1.76 plus what? 1252. So 129 times negative 1.76 times plus 1252. What do you get?
1,024.96.
1,024. Okay, I got something wrong here. Oh, what percentile? I'm sorry. What percentile? So just do from negative 9999. I thought that's what I was doing originally. I'm sorry, I messed up. So do negative, somebody, negative 9999 to negative 1.76. That'll give you your area. I'm sorry. What does that come out to be? 4 digits.
0.0392.
0.0392, and that'd be 4%. So it'd be the 4th percentile. So let's go through and answer the questions and see if we got them right. This is a good question to do for homework. That way you'll be ready for the test. But I wouldn't give you 4 parts. If I gave you 4 parts on a test, I would knock off about 3 questions off the test because they're all in here. So I like 1 per. That's what I like. 1 question per question. So, you know, it's hard to think of something so simple, but okay, the first one, I'm looking, hold on. 0.9470. We're cooking with peanut oil. All right. This one, B, is, what did we get for B? I don't see it. 0.0256. 0.0256. Well done. D or C is 0.5832. Fantastic. And this one, it says round to the nearest integer. So 0.0392 would be what? 4. And we got that question right. Question. Okay. So now I want you to be able to do 7.1 and 7.2 for homework. I want you to work on 7.1 and 7.2.